All right, here we go. Let's take a look at the next section. We're going to kind of mix it up here a little bit and start talking about polar coordinates and polar graphs. Pretty awesome. When I think of polars, obviously think of polar bears. That guy's adorable, waving hello at you. Let's do this, man. So we're so used to everything we've graphed being on the X and Y plane, but now we're going to look at the R and theta polar plane. So what is that? Well, we start with our 0 degrees or 0 radians. This is our polar axis. And then we're referencing, this is called the pole right here. It's kind of like our origin, or really it's the reference point. It's the center of everything that we're referring to. So that's our pole. And what are we going to do? Well, we're just going to draw some kind of angle off of this. So we have our theta. And then we're going to pick one of these lengths along the way. It's kind of like the radius of the circle. So what is R? R is going to stand for the length you go out. And theta is going to be the direction. So maybe you've done some of this before in science. This is big in vectors. We're going to do vectors coming up here soon in Unit 4. But we're just talking about another way to graph points. So it's pretty cool. This first section I think is pretty chill. We're just kind of getting used to it and seeing how it goes here. So here's an example. What is this? This is r comma theta. This is 2 pi over 6. So here's a polar plane here, and I'm just going to go out. Each rung here is like the radius. So I'm going to find my pi over 6. There it is. I'm going to go out 2, put a dot. Boom. Easy peasy. That's it, man. Excellent. So what about a negative? So when I talk about this 2, that means I'm kind of walking towards the angle. So I'm heading towards pi over 6. So what do you think negative means? Well, you're going to walk away from the angle. So the angle here is 7 pi over 6. So let's find 7 pi over 6. Here it is. Instead of walking towards it, we're actually going to walk away for it. So it does get kind of weird here. 1, 2, 3. I'm actually back here. So what you may be thinking is, hey, why would I name it negatively? Yeah, you don't have to. You can name these a bunch of different ways. If you don't like the negatives, you can try to avoid them, just like I try to avoid Mr. Sullivan. And you can do it however you want. Awesome. So along those lines here, let's name this different ways. So I'm going to force you to do it 4 different ways. Let's start with the positive way. So I'm looking at 5 pi over 3. Ooh, that's a terrible looking 5. Let me try that again. 5 pi over 3. And I want to walk towards it, if that's my angle. So what is my length? Well, I'm walking towards it 1, 2, 3, 4. So that would probably be how most people name it, using both positive. So I'm cool with that. Let's keep going with renaming 5 pi over 3 another way. So I went around this way for 5 pi over 3. Whoosh, that's crazy. Let's do it the negative direction. So could I do it negatively? So sure, let's keep this. I still want to walk towards that same angle of 5 pi over 3. But another way to call that would be what? So another way to call this would just be negative pi over 3. I just went pi over 3 in the negative direction. So that's totally cool if you want to do it that way. How about another way? Let's start to think about doing it with some more negatives here. So if I'm going to walk away from an angle, what angle am I going to walk away from? Well, this is the angle of interest, and see how it comes on through here to the other side, to 2 pi over 3. So I can say, hey, let me walk away from 2 pi over 3. And if I walk away from that, so I look that angle, walking away from it is back over here. Awesome. Is there another way to name it instead of calling it 2 pi over 3? Sure, I can double negative. Love it. Double negative. So I'm going to walk away from not 2 pi over 3. Can we name it in the negative direction? Sure, I went past pi. How far past? I did another pi over 3 past pi. So it looks like I'm doing negative 4 pi over 3. So there, I got double positive, 1 negative, 1 negative, double negative. So there's 4 different ways, all talking about that dot right here. So it gives us some flexibility to name these points. That's it, man. We just named polar coordinates. All right, what if I want to convert these bad boys, though? So what if I'm in polar and I want to go back to rectangular? So I got my little r theta here, but I'd really like to get back to x and y. Well, check it out. We can totally do that. Check this out. So I've got this polar coordinate system up here. So there's my polar graph. Can I overlay a rectangular? Yes, you can. Watch this, exciting. Boom, there it is. So a point can be named either way, rectangular or polar. I love that when they overlap. Kind of looks like Into the Multiverse Spider-Man or something pretty intense. But yes, we can overlap them. Awesome. All right, here we go. So let me draw like a 0 degree angle or 0 radian. And pi over 3 is something like this. And let's just say 6 is about here on it. So that's the polar. Well, if I want to convert that to rectangular, can we overlap like an xy plane on it? Sure, there's like the y-axis. There's like the x-axis. See the overlap there? And so I want to know, hey, how far over x did I go? And how far up y did I go? Uh-oh, well, look at this. This is one of our right triangles, isn't it? So we've got theta chilling in here. We've got the r here. We've got all the pieces we need. So really, you've actually done this before earlier in the chapter where I said, hey, man, how far is this point right here? Well, maybe remember x is like the cosine. So we did, r cosine theta would take us out to that direction. And then how did I do the y? Well, that was the sine. So we did r sine theta. So those are the formulas. Jot those down, have those for conversion. So can we convert this bad boy here? Sure, no problem. What's the radius? Radius is 6. What's the angle? We've got pi over 3. Boom, done and done. Picking nice friendly angles from our unit circle. Let's do y. Y is going to be 6 sine theta. So, and again, theta is pi over 3. And let's go ahead and evaluate these bad boys here. So what is the cosine of pi over 3? Well, I know that's 1/2. It's in the first quadrant. Everybody's cool and positive. Oh my gosh. Let's try that again, 1/2. And then what is the sine of pi over 3? It's going to be the radical 3 over 2. So let's clean this up a little bit. What is half of 6? Well, I get 3. What is the 2 here is going to cancel, just like the 2 canceled this to give you 3. He's going to cancel that, give you 3. So we were looking at 3 radical 3. So we just found x and y. So I converted that point to x is 3, y is 3 radical 3. Fantastic. There we go. Awesome. I got another example here. Let's do this one again here together here. So it's just following the formula, so it's not bad. The only difference here is you've got to be careful with our signs. So to find the x is going to be r cosine theta. So I've got that 5 pi over 4. And then to find y is going to be 4 sine theta. So we're really going to use this formula a lot coming up here next section and whatnot as far as converting from polar to rectangular. Ooh, that's supposed to be a pi over 4. So now just I want to make sure I'm cool here because now when I'm talking about cosine of 5 pi over the 4, where am I? Well, remember you're down there in that fourth quadrant, so this is actually going to be a negative. So this will be negative radical 2 over 2. And then when I'm looking at sine, sine again is also negative over there. So it's negative radical 2 over 2. And then when I clean this up a little bit, the 2's are going to cancel. So I get negative 2 radical 2. This will also be the same thing. It's going to cancel 2 of those. Negative 2 radical 2. And let me write that out nice and neat because that looks really sloppy. So we've got negative 2 radical 2. Negative 2 radical 2. And I always double check, does that seem like the right quadrant? Yeah, I went over and down, so I'm down here somewhere. Sure, that's that angle going through it. So I just kind of make myself a rough sketch to check it out. Rock and roll. So if we can convert one way, can we convert back the other way? Well, I hope so. That'd be a bummer if we couldn't. So now I'm giving you x and y. So remember, this is x and y, so it's kind of weird switching back and forth here. X and y. This one I definitely want you to draw like a little sketch. I think it'll really help. So just to get a ballpark, I'm over 3 of 5. I just really want to know what quadrant I'm in. That kind of cleans things up. So can I bring this back? Well, let's come over here to formula land. And let's say we were going to go, let's do a point in the first quadrant, if that's cool. So if I had a point out here, and it's x comma y, so I went over x and up y again. So I went up y. Well, guess what? We're back to that triangle, aren't we? Spoiler alert, even though if I did it x, y, I've still got the angle created here. I've still got r. Well, what relates these bad boys together? Well, I can do Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus y squared is r squared. But I'm looking for r, so what do I got to do? Let's just square root that. So we're going to square root that. So really, come over here, formula. This is going to be the square root of x squared plus y squared. Awesome. And then down here in theta, how do I find theta? Well, that's just an inverse tangent, isn't it? So I want to do inverse tangent, opposite over adjacent. So I'm going to take the inverse tangent of y over x. There it is. There's your formulas. So now we got them. Let's use them here. So I want to find r. R is just going to be negative 3 squared plus 5 squared. And then I'm going to square root it. Whoosh, there it is, right there. What is tangent? Tangent's going to be inverse tangent of y over x of 5 over negative 3. Awesome. So I got them all set up. Now let's just clean it up and have our answer here. So Can we square this? Negative 3 squared is 9. 5 squared is 25. And I'm going to square root it. So I'm really talking about what here? The square root of 34. So kind of a weird number. Don't stress out. We're going to get some weird radicals here. How about the next one? I think we're going to have to go calculator. All right, so here we go. Let's take the, not tangent. Let's take the inverse tangent of 5 divided by negative 3. And we're going to get this answer right here, negative 1.030. So let's jot that bad boy down here. So we're looking at, let me get my pencil, negative 1.030. And I know I don't have to write that last zero, but I'm such a truncator. I like to go 3 decimals and just stop writing, so I'm going to leave it in there. Awesome. So this is looking pretty good, except did you notice this? Well, I have to be in between 0 and 2 pi. So remember, the calculator is only going to give you inverse tangent between 1 and 4 quadrant. That's this restricted domain. So I'm not in there with that negative. So what do I got to do? Well, it's weird. Let's just take a look at what was negative 1. Would be something like this. That's not even where the point is. That's why I drew this. The point's up here. So if the point's up there, how far away am I? We really need to add pi to this. So we need to add pi to this right here. So that's the trickiest part here, is making sure that the calculator gives you the point of interest. So let's add pi to this bad boy and see what we get. So we're really looking at what? 2.111. I like that number. I can remember that. So what is my final answer after all this? So the R value is radical 34. And then my radians, or my angle, is 2.11. So again, that little picture saves me with this tangent. That, to me, is the hardest part, is just remembering if I got to do something there. Awesome. Let's try another example. So again, just before I get too far, I like to just say, what quadrant am I dealing with here? So I'm over 2 down 6. I'm in quadrant 4. So just got to make sure when I'm done, everything matches up. Let's just do, it's a massive plug and chug. So once you have the formulas, it's really just go for it, man. So we're looking at the square root of 2 squared plus negative 6 squared. Awesome. And then let's clean it up. I think I'm talking about 4 plus 36 here when I square them. And that is radical 40. Does this break down a little bit? Yeah, I think 4 goes in there. So I am going to clean this up a little bit. I can say this 4 goes in there 10 times. So square root of 4 is 2. So I'm going to say 2 radical 10. So I will clean up my radicals if I can, make them look a little nicer there. Awesome. Now the tough one here, the tangent. So we're trying to find theta. The inverse tangent is not the hard part. That's just plug and chug, man. So we're going to put y over x. So we're talking about negative 6 over 2. The hard part is, am I going to get the right answer? So I can look at this. Am I going to get the right answer? Well, yes, it's in the right quadrant. Tangent's going to hook me up. So that's looking good here. So let's do it. It's going to give me the angle. Let's clear that bad boy out. So I believe I have inverse tangent of negative 6 divided by 2. Except, is that between 0 and 2 pi? No. So what do I got to do to this? I got to add the 2 pi. So I got to make it fit. So I'm going to add, let's add 2 pi here. 2 pi. That just brings me back around the circle, 5.034. So in this case, we had to say, oh man, yes, it gave me the right answer, but it wasn't. It wasn't between 0 and 2 pi. So I actually had to add 2 pi to get back to it. So I don't want the negative version of this angle. I don't want this. I want to go the other way. So that's why we had the 2 pi. So in this case, theta was going to be 5 point, I forgot. I thought I could remember. Oh, I would have guessed that. 5.034. All right, 5.034. So if it does tell you where theta's got to be, you got to put theta there. So what is our final answer here? We've got 2 radical 10 as our r, and then our radians, our angle is 5 point. Let me clean. Whoa. 2 radical 10, and then 5.034. Awesome. And that is our final answer there. There it is right there. That's our point. Just converting things over. Sweet. So we're about done here. That's half of it, but we do have another way to graph points, and we've done this before along the way, either Algebra 2 or Integrated Math 3. Complex numbers. Remember A plus BI? So if you remember this was a real, A was the real part, B was the imaginary part. So together they are complex. There are 2 parts. They are imaginary and real. So we say they're complex numbers. So we had these formulas here where you could plot a point A plus BI. You could find the absolute value of it. which really was what? Let's take a look at that on the picture. If I plot this point, it's just a real and imaginary plane. So this is when we're square rooting negatives. We kind of get these imaginaries. So you go over 3 or 4. They're great because they're just like rectangular points, except it's the x is real and the y is imaginary. So sometimes even we call them x plus yi. You may see that as well too, because we're doing the same thing as a plus bi. And then the absolute value, what is the absolute value? Well, it always goes back to this right triangle here. So if I draw this in, what is a and b? Well, it's just x and y. And you're finding what this distance here, which you're really finding r. So the absolute value here is just that distance, which is just finding r. So it's all the same stuff here. Awesome. What if I ask you to name this point? Yeah, no problem. You went over 1, 2, 3, 4. So we got -4, and then you went down 3i. Rock and roll. So that is a complex number on the complex plane. So what do you think we're going to do to it? We are going to go complex polar. Woo! I love it. We gotta put it all in there. So if I want to go to complex polar, I got to get r and theta. So it's the same actual formulas here that we were doing before. If you like a and b, you can use a and b, but you're finding the absolute value. You're going to do the same thing. It's just going to be, I'm going to keep it with x and y if that's coolio. X squared, y squared. And then what am I going to do here? I'm going to inverse tangent. So it's all the same stuff, but we're just going to write it out a little bit differently when we come to the final answer here. So this is complex because it has I. It is in rectangular. I want to go to polar. So let's do it. Let's find that r is going to be the square root of -3 squared plus radical 7. Radical 7 squared, which is nice. I mean, I kind of picked that on purpose because that's 9. What happens when you square root? You just get back to where you were. So check this out. I thought, let's make one work out friendly here. So 9 and 7 is 16. 16 is cool because I know the square root of it. So it's just going to be plain old 4 like that. Awesome. Awesome. That 6 got worse and worse as we went there. I can't leave that. I can't leave that there. Okay. Now let's go to theta. What is theta here? Well, we're going to go inverse tangent. And we're going to say y over x. So we're going to say radical 7 over -3. Again, I kind of like to know, well, where am I? It's a question I ask myself a lot. Where am I? Well, I am in what quadrant? I went left and up. I don't even care how much. I just got to know that I'm in quadrant 2. So is this going to give me the right tangent? No, tangent's always 1 or 4. So if it's over there, I imagine it's going to give it to me over here. So you're going to have to do what to it? You're going to have to add pi to it. So just be careful. It's not going to hook you up. Let's see what that is here. We've got, let me go back to, where'd my calculator go? There he is. There he is. So we're going to say it is, clear that out. All right, let's type this bad boy in. I'm going to go inverse tangent of radical 7, square root of 7. And then I divide that bad boy by -3. And let's see what the calculator tells me. -0.722. So again, I'm a huge truncator. I'm not going to worry about rounding, but I got -722. Don't forget to add that pi there, though, because it did. It gave me down here. But again, I want to be up in the second quadrant. So we got to be coolio with that. So we're going to add that pi to it. So let's go back and say, add some pi. Put that in there. And what do we end up with? 2.418. That's an answer I can hang with. 2.418. Now, how are we going to write this out? So that's theta right there. So how am I going to write that out? Well, it's kind of crazy. We are going to say, we're going to write it out as that whole r cosine theta, r sine theta. So we know r is 4. Cosine of 2.418. We know this is going to be 4 sine theta. But because it's the imaginary part, it's actually 4i. And I'm going to take the sine, and I'm going to run out of room. 2.418. There it is right there. That's a monster. Sometimes what we do to make it a little bit shorter is take the 4 out of it both. See how they both have that 4? So you may see it written like this. I wrote most of my answers like this. 4 cosine 2.418. Oh my gosh, I'm having a terrible time with my handwriting today. Plus, I took the 4 out, so there's the I. So it doesn't save a ton, but I want you to be able to recognize it. Back in the day, I swear we used to use CIS, C-I-S for this. and that cleaned it up a lot. But there it is right there. Oh my goodness, close the brackets. That means just distribute the 4. There it is right there. Holy cow. Why don't you pause it and try this one and see how it goes? Good luck. All right, there it is right there. What a monster. I love it. I love it. Hopefully, you noticed that this was in the 4. I made a little sketch here. I hope it didn't trip you up that it's just -1i. So if it's not written, it's like a -1. So don't freak out. Plot it's in the 4th quadrant. So it gave it to me in the 4th quadrant. There was nothing limiting me between 0 and 2 pi. So I left it that way. If you had a 2 pi, it's totally the same answer. But you didn't have to. It's just right there. That's a big dog answer. Very impressive if you got that right there. All right, let's wrap it up. The finale is just going backwards, and we are done with this. So here I am in the rectangular complex number, and I want to go back to polar. So really, again, it's the same formula. So once you have this, and once you're done with this section, you're going to have this bad boy memorized. So we can just plug and chug back into this, our cosine theta, our sine theta. And we can see theta right there. There's theta. I can see r is right there. So really, this was probably my favorite. We're going to say, what is x? It's just going to be what? It's going to be the 3 cosine of pi over 3. So it's really the same stuff again. It's just kind of a little different notation because we got the I in there. And then let's change colors for the y. So for the y, I'm going to say it's 3 sine pi over 3. Just be careful with your signs here. Make sure we're good on everything here. So let's evaluate the first one. Oh, first quadrant, so nice. Pi over 3 is just 1/2. Down here, sine of pi over 3 is radical 3 over 2. Still not too shabby right there. So what is half of 3? Well, it's just 3/2. And then what is that? Well, nothing really simplifies. So it's 3 radical 3 over 2. So that gives us our final coordinates of, oh, not coordinates like that. We could write them like that as long as you specified. But I'm going to write them as a plus bi. So I'm going to say it's 3/2 plus, where does the I go? It actually, we don't like to put it after square roots. So I always try to put it in front of square roots because we don't want it to get underneath that square root. Long story short, there's the a plus bi, something like this. One more just to make sure we're cool. Pause it and try this bad boy, see what you come up with. All right, I tried to kind of pick a weird one here that had a 0 in it. So hopefully you got the cosine of 0. Just gives you the real part is 0 here. And then over here, you got the -1, so it gave you -4 part for the imaginary. So this is just plain old imaginary number, nothing complex about it, it's just -4i. That's it. This section had a little bit of everything. Complex, real, imaginary, trig. I love it. Mix it all together. Good luck on the practice and the mastery check. Peace out. All right, there it is there. I tried to give you a weird one where you got a 0, which is kind of nice. Hopefully you got this, -4 plus 0i, but does anybody really write that? No way. We just say it's -4. So it's actually just a real number here is all that bad boy is. That's it, man. We got complex, we got polar, we got rectangular, we got it all together. Let's mix a little trig in there. What a section here. So good luck on the master check. Hope it goes well. Peace out.